In this video, I'm going to be demonstrating how to build a machine learning trading algorithm to trade the Gold ETF, and I'm going to be using LumiBot from LumiWealth to implement and manage the algorithm. And this video assumes you're already familiar with LumiBot basics, and if you're not, then you should probably watch at least the first two videos in my series, and I'll leave a link in the description so you can do that. So with all that, we'll go ahead and jump into our coding. And I'm going to spend most of the time actually building the machine learning part of this. And so I've already set up the trading management part of the thing, which will, once we have our machine learning algorithm, take a signal and then decide whether or not to go long or go short the Gold ETF. So some of this I'll fill in after I make the algorithm. All right, some of it I've already populated. All right, so these are the basic imports I'm going to need to get some dates and to implement the LumiBot algorithm, all right, and then to do some back testing. Okay, so we're going to build a class, and it's going to inherit the strategy from LumiBot, and the strategy from LumiBot has a number of life cycle methods, and one of them is initialize, where we set up the conditions that we want the algorithm to trade under. All right, so this one just fires once we launch the file. All right, so I'm just going to tell it to check every 15 minutes, and I'm doing that so I can close the trade at the end of each day. Actually, I'm going to close it 15 minutes before the end of each day. All right, and then here is what I'm going to add after we develop our machine learning algorithm, and this is where I will implement the machine learning model and run that every day before the market opens to generate a signal. Okay, another life cycle method here, and I'm just going to set this first trade as true. All right, so this is a custom variable that I am making up. And then on trading iteration here is the main trading logic of the algorithm. And you can see it's pretty simple, right? We're going to check and see if it's the first trade, and every day it's going to say yes, at the first trade it is the first trade. And then once we run through this the first time, we're going to set that to false so we don't keep buying. All right, I'm going to pass in a symbol, I'm going to pass in a trading quantity, and that trading quantity is going to be based on this method where I'm going to use half my cash to invest in gold every day. And I'm doing that so that I don't violate the short rules, right? So I need 50% margin on a short position. All right, and then here we're just deciding if we're going long or short, and then, right, we create an order and we submit it long or short. And then 15 minutes before trading stops, we're going to close everything. All right, so we're going to minimize that overnight risk. All right, down here, it's just the logic for whether or not this algorithm is live or whether we're just going to back test it to sort of tweak it and get it to work as well as we can. All right, so for this one, I'm just going to be back testing. I'm not going to try to launch the strategy live, but I have the code here to do that if you find something that works and that you want to try live or in a paper account. All right, I should probably stop there and say, yeah, this video is for educational purposes only, and you should not use it as trading advice. All right, so that is the LumiBot piece so far. We're going to have to make a couple of changes, but before I do that, we're going to go ahead and try to build our machine learning algorithm. All right, so new file here, and I'm going to start with some imports. I'm going to get NumPy, Pandas, and Scikit-learn to implement this model. Okay, so those are our imports, and from this you can tell that, I'm going to make a support vector machine and try to build a model that will be an improvement over just buying and holding gold. All right, so to do that, I'm going to get some data, and then we're going to manipulate it a bit to build our machine learning model. All right, so I'll go ahead and use Y Finance. So I'll set a symbol. Gold ETF, I'll set a start date, and we'll go back about 5 years here. I'm just sort of arbitrarily deciding that that's how far back I want to go, and I will end not 1 year later, but I'll end at the end of 2024. All right, so we'll go and get some data here, and first thing I'll do is add some returns to that. All right, now I'm going to use close instead of adjusted close. Shouldn't really be any difference there. And then I'm going to set some lags, and I'll just start with 5. All right, so in case you're not familiar with it, support vector machine is a binary classifier, and it's going to look for an array of zeros and ones. It's going to try to discern a pattern in that and then predict some value, 0 or 1, as the output, right? So in this case, when it's 0, we'll go short, and when it's 1, we'll go long. Okay, so I'm going to add a column to the data frame for each one of the lags, and it's going to be the return from a previous day. So each lag I move out is going to be a return shifted down by 1 day. And eventually, I'm going to use those 5 returns, the 5 previous returns, to predict the 6th day. All right, I'm not going to be able to predict the return, so eventually I'm going to have to transform those into a 0 or a 1 so that I can fit the support vector machine. All right, so I'll make some columns here, and I will use a list comprehension. All right, and I'll use some of the Copilot suggestions, all right, but I'm not a big fan of the nebulous I as a variable. All right, so I will call it a lag because that's what it is. All right, and yeah, we're going to start at 1, and we're going to go out to 5 here. All right, I'm going to set a counter variable and then loop over this in a for loop. All right, so it's going to be for column in columns. All right, and then it looks like, yes, I can accept what Copilot has come up with there. All right, so it does a pretty good job, but you just have to do a reality check when you're using these AI tools to finish your code for you, so you don't have to later go back and debug it. All right, so I'm going to reorganize the data frame here. Before I do that, let's just take a look at what we have so far. All right, so I'll get the first 10 rows there, and so you can see what happened here, right, as we're shifting along, right? We have a bunch of lags here, and the return is kind of hidden in here. All right, so I don't actually need all this data. I can probably just get the close and be happy and probably see a bit more. All right, so I'll leave that there for now. We'll reorganize the data. I'm going to get rid of all those not a number values, and I'm going to put the return out on the end so it kind of corresponds to all those lags. We'll get the close, get the columns, and we'll get the return. And then I'm going to drop all those not a numbers. All right, we need to do this anyway because the support vector machine is not going to handle not a numbers. All right, so basically I went back 5 years, got some data, put some returns on there, and then I offset the returns by 5 days, so then I can use the previous 5 days to predict the 6th day. All right, let's see what that looks like so far. Okay, so here's a pattern, right? Previous 5 days. On the 6th day, that's what the return was. And we're saying that, oh, once I fit a support vector machine, I'm going to be able to use this pattern to predict that return. Okay? All right, let's move on. Okay, so I'll transform those returns into zeros or ones. All right, and I'm going to, use MP where. Okay, it's greater than 0, it's going to be a 1, otherwise it's going to be a 0. And we're going to assume that, okay, there aren't any 0 change days. All right, once in a while it may happen, and on a 0 change day, we would go short. Okay, I have to also transform the return, and so I'm going to add a new column to do that. All right. So same logic, right? 0 or 1, all right? Except for here, right? Instead of saying 0, we're going to say -1 to indicate, okay, that's where we should go short. All right, so let's take a quick look at that. Sort of override what Copilot's telling me to do, and we should be able to test that. All right, so there we are. All right, so we can see that, oh, for the previous 5 days, right, this pattern, right, down, down, up, up, up. All right, and direction was up after that. All right, and then we had an up, a down, down, up, up, and then, oh, direction went down. All right, so what we're hoping to do is use this pattern to fit our support vector machine and do something better than just sort of buying and holding. All right, so we're just about ready to do that. We're going to go ahead and build the model and set a few hyperparameters here. Kernel is going to be linear, and we also have to set a gamma. Set that as auto, and I'm going to ask it to also calculate the probability. All right, so the default is not to do that, and yes, I want to do that. So I'm going to split it. I'm going to get the data up until some fraction of the data frame. Okay, we'll create a copy, and then we'll fit our model. And it's going to be based on those lags and then the direction. All right, and then we'll just get a crude estimate of how this model does. So we'll get a win rate, and that's going to be the accuracy score when we try to predict the direction. All right, so I'll just print that off now instead of the data. Okay, let's see if that works. Okay, so I'm getting a warning message here from Panda saying that I'm trying to do something to a copy, and I'm just going to go ahead and ignore that. But the accuracy we're getting is 53%. All right, so we might want to change our lags and see if we can get something a bit better. All right, something a bit higher than 53%. All right, so let me try a couple more lags there. Go up to 7, see if it gets any better. And it looks about exactly the same, 52.9, right? I could try 6 and see if there's a sweet spot in there somewhere. I could try more. All right, looks like it's about the same, no matter what I do here. 5, 6, 7 lags. Okay, all right, so we'll just leave it with 5. And then we're going to actually test the model and see, okay, well, what's it do on data it hasn't seen yet? So I'll make some test data here, and I'm going to go the other direction, right? So start at that 80% mark and go out to the end. We'll put a prediction in there, and we'll try to predict using the test columns, so that pattern of zeros and ones, to get a prediction. And we can compare that to the actual direction and kind of get a visual confirmation of, okay, what's the model doing at a high level. All right, so I'll print some of that, and just a few rows. All right, and then we can get the win on this as well. Okay, let's try that. All right, so the win rate actually went up a bit on the test set, right, from 53 to 54%. And here, right, we can see the actual direction versus the predicted direction, all right, and how frequently we're right. Okay, so just looking at 10 rows, yep, we can see we're right about half the time, all right. To get up to that 54%, I guess we need more data. All right, so this is just using existing data, right, and I need to forecast, in this case, right, it goes out to the 16th of January, and what I need to do is predict the 17th of January, so data that it definitely hasn't seen yet. Okay, so I have to add that piece in. All right, so we'll call this a forecast, and what I want is the last row, nothing to do with the model at this point. All right, so I'm going to get the last row, and I'm going to turn that into a list. All right, so let's just see what that looks like. All right, so there's that last row, right? I turned it into a list. All right, so there's our pattern, right? And there's our direction. Okay, so it looks exactly like this. Get rid of that. All right, and I'm going to drop off the first value so I can add in my predicted value. All right, so I get everything except for the first value. And then I'm going to get the direction. Okay, so there's our 1 and a 0, and then I'll just append that direction onto the forecast. All right, and now rather than printing the whole thing, I'm going to pass this into the model and predict based on that forecast. All right, and I don't need that. I just want the value. Let's see, where's the syntax error? Right there. Oh, and before I do that, let me get the... I'm going to get another warning message if I don't put some column labels on here that says, oh, the columns are not labeled and the model is labeled. So I'm going to turn this back into a data frame. All right, let's try that. So it's predicting, right, that we should go short. All right, and then we can also get the probability of that prediction. So copy that again. And instead of predict, it's going to be predict proba. All right, let's try that. All right, and yeah, the index 1 position is the prediction probability, so 53% chance of being right, something like that. Okay, or that's what the model predicts. Okay, so a lot of little work here to, right, just sort of get there. Some of it I printed off, obviously, when I run the algorithm, I'm not going to be printing off these values. All right, I'm just sort of doing this as a proof of concept. And then, do I really want to put all this code inside my algorithm, all right, and sort of muddy the water there? And no, I really don't. So what I'm going to do is transform this into a class, and I'm going to import the class into this LumiBot algorithm that I sort of partially set up in advance. All right, and then, okay, I'm not going to have to write all the code because Copilot's going to write most of it for me, and then I'll just have to make a few tweaks. All right, so let's do that. New file, we'll call it machine learning class, and I'll start off by importing the same stuff. All right, and you can see already that it is doing a pretty good job based on what I've done in the past and trying to just sort of repeat that. All right, the difference here is going to be, I'm writing a class, and the class is going to be machine learning, and then it's going to need an initializer, right? And it's going to need some methods to do some of the stuff that I just did. And you can see, Copilot is suggesting all this stuff. And so rather than spending all the time writing the class, all right, I did sort of a scratch sheet there, and now I can implement the class here. And yeah, there's a few changes that I have to make in order for this to run. All right, but for the most part, it does everything I need it to do, and I'm just going to import the machine learning class into the algorithm and put in a few lines of code over there, and then we can run and back test this strategy. Okay? All right, so rather than debugging this, I've already done it, and I'm going to just copy that file in here. Did the file copying here, filled in the parameters that were missing originally from our trading bot. All right, I'm importing the ML class, and we're going to trade gold. We're going to go back to the first of the year in 2020. We're going to use 7 lags. All right, and then all this was the same. Here's me go ahead and training that model, and based on however many lags I'm using, and I'm going to generate the signal from that forecast, just like I did in the scratch file. All right, so if it turns out that this doesn't work the way you want, you can come in here and you can tweak the lags. It's possible that you can tweak some of the hyperparameters in the actual model over here. All right, so we can change a C, right? And support vector machine works on essentially what they call a lane, and the C kind of controls how wide that lane is. So a smaller value is going to give you a wider lane, and the idea here is that we're trying to minimize misclassifications with a lane width. So a narrower lane, right, is basically going to turn into a logistic regression, and then right, whether or not you're on one side of the lane is going to essentially be the same as it would in logistic regression. All right, so we've made a wider space in there, sort of a no man's land, where hopefully we don't get too many misclassifications. And you saw how accurate it was. It wasn't super accurate. I guess I'm not expecting that this thing performs super well, but let's go ahead and try it and see how it works. All right, so I'll just go ahead and run this and see what we get. All right, now I'm just running it for, I think, a couple of months of last year, so like the end of October to the end of December, just to speed this along a bit. All right, so let me go back to that first. All right, so we get 2 reports, and we can see that, right away the first day we went short, and we can see that, we got that cash when we went short, and then, right, you can kind of see there, we closed it at the end of the day. The next day we went short again, right, and then there was a weekend short, and then a couple of longs, short, and so forth. All right, so that's essentially how you interpret this, and we can see, all right, where is our portfolio balance here versus, where's the market? All right, and then let's go ahead and look at this detailed report from QuantStats, and it's saying that, if we extended this out from 2 months to a year, we would lose 2%. All right, there's those parameters that I set. All right, and then we can kind of look at, what was the actual return, right? right? So my actual return was close to zero, and gold actually went down 6% in the same period. And if gold kept going the way it was, then you would have lost 33%. With a buy and hold, we would have only lost 2% under this strategy. All right. Obviously, we want it to go up, but in a downward market, at least it looks like we have reduced quite a bit of volatility in investing in gold. All right. And we can, this kind of plays out in the rest of the report here too. So here's our returns under the strategy, and here's our returns under buy and hold. All right, so obviously gold was moving down in this period. All right, and then, we probably need a longer period of time to see, how would it perform actually over a year or 2 years or something like that. All right, but I have a free account at Polygon, and if I try to get more data, it's going to sort of time out and take a lot of time to get the data. All right, so lots of stuff you can do with this, and maybe it's too simple to just use returns. Maybe there are some other indicators you need to add in there and turn into a binary in addition to returns to see if you can generate a better model. But at least this should give you a place to start implementing machine learning alongside LumiBot, and I hope it helps.